Welcome back to Dr. Fogg's TV.
Good day everyone, I remain your humble Dr. Fox. So today we are looking at mathematics, indices, that is laws of indices. So these are the questions that we have for now because I'll still solve more questions. So this is just the first part of indices. So but before we solve our questions, let us take a look at the laws of indices because there are 7 laws of indices which will guide us through to solving these questions. So laws of indices. So the first law, I have A raised to power m times A raised to power n. It means that I have A raised to power n multiplied by A raised to power n. The number down is the base, the number up is the power. But since I'm still using letter to give us the laws, that means A is my base, n is my power. M and n are the powers. So A is the base, M and n are the powers. So when you have numbers of the same base and you have multiplication between them, it means that you pick one of the base and add the power. Which means that if I have 10 raised to power 6 times 10 raised to power 2, it is simply 10 raised to power 6 plus 2, which is 10 raised to power 8. The second law of indices, A raised to power m divided by A raised to power n. When you have the same base and you have division between them, you pick one and subtract the power, which means that multiplication is to addition as division is to subtraction. So here I have 10 raised to power 6 divided by 10 raised to power 2. It is simply 10 raised to power 6 minus 2, that is 10 raised to power 4. The third law of indices, if I A raised to power 0, that is 1. It simply means any number or any base raised to power 0 is 1. The first law of indices, I have A raised to power n, I have n, which means that when you have double power, the powers are to multiply themselves. Here becomes A raised to power n times n, that is A raised to power n n. The fifth rule of indices, I have A raised to power minus n. A raised to power minus n. The first thing I do, anytime your power has negative, you remove the negative by looking for the reciprocal of your base. Now, what is the reciprocal of A here? Here becomes 1 over A raised to power n. The sixth rule of indices, I have A raised to power n over n. Now, when your power is in fraction, you know in fraction we have numerator and we have denominator. So when your power is fraction, your numerator still maintains power and your denominator becomes root, which means that here becomes square root then A raised to power n, which means that if I have here 2b, A raised to power 3 over 2, it becomes square root of A raised to power 3. Then the last rule of indices, I have A over B raised to power m over n. I have A over B raised to power m over n. Now, your power and base are both in what? In fraction. So your power, from your power, the numerator still maintains the power and denominator becomes root. So here becomes what? Root, then a over b. I have my n here, raised to power what? N. So these are the 7 laws of indices. So these are the laws that will guide us through to solving these questions. So having talked about the laws, let's move forward to solve the questions. So question 1, I have 0.008 raised to power 1 over 3. 0.008 raised to power 1 over 3. Now first, I have to convert this decimal to fraction. Now how do I convert decimal to fraction? I want myself that after the decimal point, how many numbers do I have? There are 3 numbers after the decimal point, which means 3 zeros. That means I divide by 1000. If after the point I have 2 numbers, that is 2 zeros, I'll divide by 100. If after the point I have just one number, a number, that is 1 0, I'll divide by 10. So this after the point, I have 3 numbers which represent 3 zeros, and I'll divide by 1000. So here becomes 8 divided by 1000 raised to power 1 over 3. Pertaining to our law of indices, from our power, the number up maintains the power, number down becomes the root. So here becomes cube root of 8 over 1000 raised to power 1. Now this cube root means that I need a number such that when I multiply the number by itself 3 times, I will get 8. And I also need a number such that when I multiply by itself 3 times, I will get 1000. Now, which number will I multiply by itself 3 times that will give me 8? That is 2. And for 1000, that is 10 raised to power 1. Yes, 2 here 1, 2 here 5. This is 1 over 5. Then question 2, I have 4 raised to power 1 over 4, then raised to power 6. According to our law of indices, when you have double powers, it means that the powers are to multiply each other. So here is 4. Now, 1 over 4 times 6, Abi, here becomes 6 divided by 4. I can divide. I have here 2 in 4, 2, 2 in 6, 3. Here becomes 4 raised to power 3 over 2. Which means that the number down becomes square root, number up becomes power. Now, square root of 4 is 2. Then 2 raised to power 3 is 8. Means that if I multiply 2 by itself 3 times, I will get 8. 2 times 2 times 2. And I move to number 3. I have 125 raised to power 1 over 3 times 49 raised to power 1 over 2 times 10 raised to power minus 1. Now here becomes cube root of 125 raised to power 1 times square root of 49 raised to power 1 multiplied. Now this is 10 raised to power minus 1, which means that my power is what? Negative. And what will I do? And I'll look for a reciprocal of the base. So here becomes what? 1 over 10 raised to power 1. So cube root of 125 is 5, which means that if I multiply 5 by itself 3 times, I'll get 125. The raised to power 1 times square root of 49 is 7 raised to power 1 times 1 over 10. So here is 5 times 7 times 1 over 10. So that's 5 here 1, 5 here 2. My answer becomes 7 over 2, which is 3 whole number 1 over 2. So we have solved 1 to 3. It remains number 4, number 5, and number 6. I have 16 raised to power 1 over 2 multiplied by 8 raised to power minus 4 multiplied by 3 raised to power minus 2 over 3 divided by 8 to 1 raised to power minus 2 over 3. Now in this case, I know I have square root of 16. And I'm coming here to do what? Reciprocal of 8. Then here, there is no cube root of 3. Don't forget that when your power is a fraction, the number down in the fraction, that is denominator, becomes the root. And here, there is no cube root of what? It's 1. Since I can't get those ones, and I will break all of them to be in the same base. Which means that if there is 16, and when I have 16 and 8 are multiples of 2, which means that I can break them to 2 and they will have their respective powers. So this is 16. How many 2 will I multiply that will give me 16? That is 4. Here becomes 2 raised to power 4, then times 1 over 2. That was the initial 1 over 2 that came with the question. Times 8 is 2 raised to power 3 multiplied by minus 4. Multiply here is 3 raised to power minus 2 over 3 divided by 81. If I multiply 3 4 times, I will get 81. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. So here is 3 raised to power 4. And I have minus 2 over 3. Now, here I have 2 here 1, 2 here 2. 2 times 1 is 2. Here becomes 2 raised to power 2 times here 2 raised to power minus 12. 3 times minus 4 is minus 12. Then times here is 3 raised to power minus 2 over 3 divided by here is 3 raised to power minus 8 over 3. Now, here I have the same base and I have multiplication between them. This is our first law. I will pick one and add. That is 2 plus minus 12 times. I have the same base here and I have division between them. I will pick one and subtract. Minus 2 over 3 minus 8 over 3. So this is minus 2 over 3. Because of this division, I'm having this minus. Then this one also have what? Negative. This one I'm having double minus. So here becomes 2 raised to power 2. Plus times minus is minus. Times 3 raised to power minus 2 over 3. Minus times minus is plus. So here becomes 2 raised to power minus 10. Because 2 minus 12 is minus 10 times here becomes 3. Now, since I have the same denominator, I don't need to find LCM. So I'll just have minus 2 plus 8, that is 6. Then I have 6 divided by 3. So 3 here 1, 3 here 2. So here becomes 2 raised to power minus 10 times 3 raised to power 2. Here becomes 1 over 2 raised to power 10 times 9. Here becomes 9 over 1024. 2 raised to power 10 is 1024. That's my final answer. That is number 4. So very quickly, we move to number 5. Number 5. 2 raised to power 5 times 4 raised to power minus 2 divided by 2 raised to power minus 3 times 2 raised to power 6. Now these ones are multiples of 2, but they are all in base 2. So I have to change 4 to base 2. So here is 2 raised to power 5 times here is 2 raised to power 2 times minus 2 over 2 raised to power minus 3 times 2 raised to power 6. So here becomes 2 raised to power 5 times 2 raised to power minus 4. That is 2 times minus 2 divided by 2 raised to power minus 3 times 2 raised to power 6. So here becomes 2 raised to power 5 plus minus 4 divided by 2 raised to power minus 3 plus 6. Why am I adding the powers? Because I have multiplication between them. So here becomes 2 raised to power 5 plus times minus is minus. that is minus 4 over 2. Minus 3 plus 6 is 3. So here becomes 2 raised to power 1, then divided by 2 raised to power 3. Because 5 minus 4 is 1. Here becomes 2 raised to power 1 minus 3. Since I have division, I'll pick 1 and subtract. So here becomes 2 raised to power minus 2. That is now 1 over 2 raised to power 2, which becomes 1 over 4. So, because I have a negative sign as the power is negative 2. We are looking for the reciprocal of the base. So, move to the last one, which is number 6. This is 25 raised to power 2 over 3 divided by 25 raised to power 1 over 6. We have 1 over 5 raised to power minus 7 over 6 times 1 over 5 raised to power 1 over 6. So here, I have to break all of them to a base of 5. So here becomes 5 raised to power 2 times 2 over 3. Yes, 25 is 5 raised to power 2. When I multiply 5 2 times, I will get 25. Divided by 5 raised to power 2 times 1 over 6 over. Now, this 5, I am breaking it up. It becomes 5 raised to power minus 1 times minus 7 over 6. Now, this is 1 over 5. I have invisible 1 here. This 5 is 5 raised to power 1, positive 1. So, when you have a positive power and you are breaking it up, it becomes negative. If it's a negative power, you are taking it up, becomes positive. So because I have it to be 5 raised to power 1, now let's assume this place is 5 raised to power 2. If I'm taking it up, it becomes 5 raised to power minus 2. So what I have here times the same thing that goes to this. Here I have invisible 1. So taking it up is 5 raised to power minus 1 times 1 over 6. So here becomes 5 raised to power 4 over 3. That is 2 times 2. Divided here. 2 here 1, 2 here 3. 5 raised to power 1 over 3. Divided by 5. Minus 1 times minus 7. That is plus 7 over 6. Times 5 raised to power minus 1 over 6. So here, I will pick 1 and subtract the power. This becomes 5 raised to power 4 over 3 minus 1 over 3 divided by 5 raised to power 7 over 6 plus minus 1 over 6. So here becomes 5. 4 minus 1, yes, 3 over 3 divided by 5 raised to power 7 over 6 plus times minus is minus. So here becomes 5 raised to power 3 over 3 divided by 5 raised to power 7 over, 7 minus 1, that will give me 6 over 6. Because I have the same denominator, so I don't need to find out CL. So here, 3 here 1, 3 here 1, 6 here 1, 6 here 1. Here becomes 5 raised to power 1 divided by 5 raised to power 1. It becomes 5 raised to power 1 minus 1. That is 5 raised to power 0, which is 1. So we have solved the 6 questions, 1 to 6. So very quickly we move to another part of indices. We have done the first part of indices, but like I said earlier, indices has different parts. So this is another part of indices, which says indices in algebraic terms and algebraic powers. Indices in algebraic terms and algebraic powers. So the first question, number 1, I have cube root of 27a raised to power minus 6. Now, Cube root of 27 is 3. Cube root means which number will now multiply by itself 3 times that will give 27. And that number is 3. 3 times 3 times 3 is 27. Now, I have my A here. Raised power minus. Minus what? Now, root of a power is the power divided by the root. So here becomes minus 6 divided by 3. That is minus 2. So here becomes 3 over A raised power 2. So I can leave my answer like this. I can also leave my answer this way because this is negative and the minus 2 is only for A. Then I look for a reciprocal, it becomes what? Oh, divided by, that is 3 over A raised power 2. So that is number 2. Now let's assume that here was square root. I will do minus 6 divided by 2 because 2 is the number that represents square root. So question 2, I have cube root of 27 x raised power 3 y raised power 9. Cube root of 27 x raised power 3 y raised power 9. Now cube root of 27 is 3. Cube root of a power is the power divided by root. So here is 3 divided by 3, that is 1. Here becomes x. 9 divided by 3, that is 3. Y 3. So here, number 3, I have square root x raised power 2 times 4 raised power n plus 1 divided by 2 raised power 2n multiplied by 16. Now I will break all of this to a number in base 2. So here is square root. 8 is 2 raised power 3, then multiplied by 2. This 2 was the 2 that came with the question. Is the 2 rather that came with the question. Times 4 is 2 raised power 2, and I have my n plus 1. Divided, here is 2 raised power 2n times 16 is 2 raised power 4. So here becomes square root. Here is 2 raised power 6 because 3 times 2 is 6 times 2. Here 2 times n is 2n. 2 times 1 is 2. Here is 2 raised power 2n times 2 raised power 4. So here becomes square root. Here I will pick one base and multiply the power. Here is 2 raised power 6 plus 2n plus 2 divided by 2 raised power 2n plus 4. So it becomes square root of 2. Now 6 plus 2 is 8. I cannot add 6 plus 2n plus 2n. That give me 10n. It's very wrong. Because this is a number and letter. It's different from these two that are without letter. So here is 2 raised power 2n plus 8 divided by 2 raised power 2n plus 4. So here is square root of 2 raised power 2n plus 8 divided by 2 raised power 2n plus 4. So here becomes square root. I'll pick one. Here is 2 raised power 2n plus 8 minus 2n plus 4. Why am I reading minus? Because I have what? Division. So here is square root of 2 raised power 2n plus 8 minus times plus minus 2n minus times plus minus 4. So here becomes square root of 2n minus 2n is 0. Then 8 minus 4 is 4. Now, what is the square root of 2 raised power 4? You can either do it this way, that 2 raised power 4 is 16. And square root of 16 is what? Is 4. Or I can say here that power divided by root. And the number that represents square root is what? Is 2. So 4 divided by 2 is 2. Here becomes 2 raised power 2 and that is 4. So this is the first 3 questions. So we solve the last one. I have 3 raised by x minus 1 times 9 raised by x plus 1 times 27 raised by minus x divided by 81 raised by 5x minus 3. So this is number 4. Now all these numbers are multiples of 3. So I can break all of them to a number in base 3. So here becomes 3 raised by x minus 1 times 9 is 3 raised by 2. I have x plus 1 times 27 is 3 raised by 3. Then what? Minus x. Divided by 81 is 3 raised by 4. I have 5x minus 3. So here becomes 3 raised by x minus 1 times 3. I open the brackets. Here becomes 2x plus 2. How did I get that? 2 times x, 2x. 2 times 1 is 2. Times 3. 3 times minus x minus 3x. Divided by 3 raised to power 20x minus 12. How did I get that? 4 times 5x, 20x. 4 times minus 3 minus 12. So from the numerator, I will pick 1 and add the power. Why? Because I have the numbers in the same base and I have multiplication between the numbers. So here is 3 raised by x minus 1 plus 2x plus 2 plus minus 3x. Okay, let me use this for now. Let me continue with this. Divided by 3 raised by 20x minus 12. So here is 3 raised by x minus 1 plus times plus, that is plus 2x, plus times plus, plus 2x, oh, plus 2, sorry, then plus times minus, minus 3x, divided by 3 raised by 20x minus 12. So here is 3, x plus 2x, 3x, 3x plus 3x, 7, minus 1 plus 2, 1, divided by 3 raised by 20x minus 12. Here becomes 3 raised by 1 because 0 plus 1 is 1. Minus, division is there, so I have to supply the power. 20x minus 12. So here becomes 3 raised by 1 minus times plus minus times minus plus. Here becomes 3. 1 plus 12, 13 minus 20x. That is final answer. So indices in algebraic terms and algebraic powers. So you are also done with this part of indices. This is another part of indices, which is indices involving equation. Now we have the indices involving linear equation. We have one involving simultaneous equation. We also have one involving quadratic equation. So these are the ones that involves linear equation. So number 1, I have 2 raised to 7 equals to 8 raised to 5 minus x. Now, the base here is 2, the base here is 8. So I have to bring the base of 8 down to 2 because there is no way I can carry base of 2 to 8. So here becomes 2 raised to 7. How many 2 will give me 8? That is 3. Here becomes 2 raised to 3. Then multiply by 5 minus what? X. So this is 2 raised to 7 equals to 2. 3 times 5 is 15. 3 times minus x minus 3x. Now, when you have the same base and you have equal to between them, they will cancel out. Now don't forget, there are lots of indices. When you have the same base and you have multiplication you pick one of the base, you add the power. When you have the same base and you have division, you pick one of the power and subtract. Now when you have the same base and equal to sign between them, the base will cancel out and the power becomes the base. So 2 cancel 2 here. Here becomes 7 equals to 15 minus 3x. Then I collect like terms. Here becomes 7 minus 15 equals to minus 3x. 7 minus 15 is minus 8 equals to minus 3x. Minus cancel minus, divide by 3, divide by 3. 3 cancel 3, x is 8 divided by 3, which is 2 number 2 over 3. So move to number 2. Number 2, 27 x minus 2 equals to 729. So 27 and 729 are multiples of 3. So I can break both of them down to a number in base 3. So 27 is 3 raised to 3. Here is x minus 2. Now 729 is 3 raised to 6. Let us do mathematics. 3 times 3, 9, times 3, 27, times 3, 81, times 3, 243, then times 3 again, 729. That is 6. So here is 3 raised to 6. Here becomes 3. I'll put in brackets. Here is 3x minus 6 equals to 3 raised to 6. The base will cancel out each other. 3 take away, cancel 3, sorry. Here becomes 3x minus 6 equals to 6. I collect like terms. Here is 3x equals to 6 plus 6. 3x equals to 12. Divide by 3, divide by 3. 3 cancel 3. 3 here 1, 3 here 4. So my x equals to 4. So move to number 3. So move to number 3. Now for number 3, I have 3 raised to 1 over y is equals to 1 over 27 raised to 2 over 3. So 3 raised to 1 over y equals to 1 over 27 raised to 3. Here becomes 3 raised to 1 over y equals to 1 over 3 raised to 3. And I have 2 over 3. So the 7 is 3 raised to 3. So here becomes 3 raised to 1 over y equals to. Now, this is a positive power. I will bring it up because it was negative. That is 3 raised to minus 3. Then times what? 2 over 3. This over 3 here. So for me, I know that 3 here 1, 3 here 1. 3 is 3 raised to 1 over y equals to 3 raised to minus 2. I get minus 2 minus 1 times 2. So 3 cancel 3. 1 over y equals to minus 2. Minus 2y equals to 1. What did I do here? Cross multiply. I can put here over 1. So divide both sides by minus 2, minus 2. This cancel this cancel this. Why? Because minus 1 over 2. So we have solved the first 3 questions. Between number 4, number 5, and number 6.
Action.
I have 5 raised to x minus 3 divided by 25 raised to 3x minus 4 equals to 1. So I'm taking all of these to a number in base 5, including 1. So here becomes 5 raised to x minus 3 divided by 25 becomes 5 raised to 2. I have 3x minus 4. 1 becomes 5 raised to 0. Don't forget that anything raised to 0 is what? 1. So here becomes 5 raised to x minus 3 divided by 5. 2 times 3x is 6x. 2 times minus 4 minus 8 is equals to 5 raised to 0. So I'm coming here. Let me divide this. Here is 5 raised to x minus 3 divided by 5 raised to 6x minus 8 equals to 5 raised to 0. So from this division, I will pick 1 and subtract the power. So So here becomes 5 raised to power x minus 3 minus 6x minus 8 is equals to 5 raised to power 0. So here becomes 5 raised to power x minus 3 minus times plus minus times minus plus equals to 5 raised to power 0. So here is 5 x minus 6x, that is minus 5x. This is as well as asking you 1 minus 6, that is minus 5. So minus 3 plus 8, that is plus 5, equals to 5 raised to power 0. So this cancel this, minus 5x plus 5 equals to 0. Minus 5x becomes 0 minus 5, minus 5x becomes minus 5. 0 minus any number is negative that number. So minus cancel minus, divided by 5, divided by 5. 5 here 1, 5 here 1, 5 here 1, 5 here 1. So my final answer says 1. So that's number 4. So we move to number 5. Number 5. So I have 2 raised to power 1 minus y times 2 raised to power y minus 1 divided by 2 raised to power y plus 2 equals to 8 raised to power 2 minus 3y. So here, okay, let us cross multiply. In this case, I can cross multiply, I can solve this first, then equals to this. So here becomes 2 raised to power 1 minus y times 2 raised to power y minus 1 equals to 8 raised to power 2 minus 3y times 2 raised to power y plus 2. Cross multiply. So I'm breaking this 8 to a number base 2. So here becomes 2 raised to power 1 minus y plus y minus 1. Division, sorry, multiplication equals to, here becomes 2 raised to power 3. I have 2 minus 3y, then times 2 raised to power y plus 2. Here becomes 2 raised to power 1 minus y, plus times plus, plus times minus, minus, equals to 2 raised to power 6 minus 6, no, minus 9y. Yes, because 3 times 2 is 6, 3 times minus 3 is minus 9, then times 2 raised to power y plus 2. So here becomes 2, 1 minus 1 is 0, minus y plus y is 7, that is 0 plus 0, which is 0, equals to 2 raised to power 6 minus 9y plus y plus 2. Because I have multiplication, so I'm adding the power. So here becomes 2 raised to power 0 equals to 2 raised to power 6 minus 9y plus times plus times plus 2. So here is 2 raised to power 0 equals to 2. Now 6 plus 2 is 8. Minus 9y plus y minus 8y. So here becomes 2 raised to power 0 equals to 2 raised to power 8 minus 8y. So 2 cancel out 2. So here is 0 is equals to 8 minus 8y. I will collect my like terms, which is 0 minus 8 is equals to minus 8y. 0 minus 8 is minus 8 equals to minus 8y. Minus cancel minus, divide by 8, divide by 8. 8 here is 1, 8 here 1, 8 here 1, 8 here 1. My y says 1. So that's number 5. I'll move to the last one, which is number 6. I have 8 raised to power x over 2 equals to 2 raised to power 3 over 8 times 4 raised to power 3 over 4. So I'm taking all of them to a number in base 2. Here is 2 raised to power 3. I have x over 2 plus 2 raised to power 3 is 8. Here is 2 raised to power 3 over 8 times, here is 2 raised to power 2. I have 3 over 4. 4 is 2 raised to power 2. So here becomes 2 raised to power 3x over 2 equals to 2 raised to power 3 over 8 times 2 here 1, 2 here 2. 2 raised to power 3 over 2. So here becomes 2 raised to power 3x over 2 equals to, I'm picking 1 here and I'll add the power. That is 2 raised to power 3 over 8 plus 3 over 2. I'll find the LCM, which is 8. 8 divided by 8 is 1. 1 times 3 is 3 plus 8 divided by 2 is 4. 4 times 3 is 12. So here becomes 2 raised to power 3x over 2 equals to 2 raised to power 15 over 8. 2 cancel 2. Power becomes base. Here is 3x over 2 equals to 15 over 8. So here is 15 times 2 equals to 3x times 8. So here becomes 30 equals to 24x. Divide by 24, divide by 24. This cancel this. 6 can go. 6 here 4, 6 here 5. So my x becomes 5 over 4. So we are done with this part of indices, which says indices involving equation. So we are still under indices involving equation. Like I said earlier, we have the one that involves linear equation, we have the one that involves simultaneous equation, and we have the one that involves quadratic equation. So we just did one of linear. Now this is one of simultaneous equation. So question 1, I have 2 raised to power x plus y equals to 16. Equation 1. So let me finalize equation 1. For equation 1, I'll break them to the same base. Here is 2 raised to power x plus y equals to 16 is 2 raised to power 4. 2 cancel 2. X plus y equals to 4. This is equation 1. For equation 2, I have 4 raised to power x minus y is equal to 1 over 32. So here is 2 raised to power 2. I have x minus y equals this 32. This is 1 over 32. We have 32. 2 raised to power 5. So here is 2 raised to power 2x minus 2y. 2 times x is 2x. 2 times minus y minus 2y equals to, this is a positive power, and bringing it up becomes negative. That is 2 raised to power minus 5. So here becomes 2. Okay, here 2 cancel 2. So it becomes 2x minus 2y equals to minus 5, equation 2. So let me have my equations again. Here x plus y equals to 4, equation 1. 2x minus 2y equals to minus 5, equation 2. So you can see that this is now a simultaneous equation. So from here, I want to use elimination method. So if I want to eliminate one of my variable or one of my unknown must have the same coefficients. So since they don't have the same coefficients, here for equation 1, the coefficient of x multiplied by equation 2, and from equation 2, the coefficient of x multiplied by equation 1. So for equation 1, our coefficient of x is 1. So I bring it here times 1. For equation 2, our coefficient of x is 2. So here times 2. So anytime you want to eliminate, you must make sure that one of the unknown have the same coefficient. It does not have the value here, you bring it here. The value here, you bring it here. So 2 times x is 2x. 2 times y is 2y. 2 times 4 is 8. I'll call this equation 3. 1 times 2x is 2x. 1 times minus 2y minus 2y. 1 times minus 5 minus 5, equation 4. Now I can eliminate with my minus. 2x minus 2x is what? 0. Here becomes 2y minus 2y is equals to 8 minus 5. Look at it again. 2y minus 2y equals to 8 minus 5. So here is 2y. Minus minus is plus. You all know that. So this is 2y plus 2y is equals to 8 plus 5. So 2y plus 2y is 4y equals to 13. Divide by 4, divide by 4. This cancel this. Y is 13 over 4. So I come here and say substitute y equals to 13 over 4 into equation 1. Into equation 1. So this is x plus y equals to 4. So this becomes x plus 13 over 4 equals to 4. I will correct that terms. X becomes 4 minus 13 over 4. Find the LCM, which is 4. 4 divided by 1, 4 times 4, 16. 4 divided by 4 is 1 times 13, 13. So my x becomes 3 over 4. So therefore, x is 3 over 4 and y is 13 over 4. So this is the first question of indices leading to simultaneous equation. So I move to the second one. So number 2, I have 27 raised to power x over 81 raised to power x plus 2y equals to 9. So here, this is my equation 1. So I want to sort out my equation 1 before I bring in my equation 2. So here becomes 3 raised to power 3x divided by 3 raised to power 4. I have x plus 2y is equals to 9 is 3 raised to power 2. So here becomes 3 raised to power 3x divided by 3 raised to power 4x plus 8y equals to 3 raised to power 2. That will be 4x plus 8y. So here becomes 3 raised to power x divided by 3 raised to power 4x plus 8y equals to 3 raised to power 2. So here becomes 3 raised to power x minus 4x plus 8y is equals to 3 raised to power 2. Because this division, I'll pick one and subtract power. So here becomes 3 raised to power x minus times plus minus times plus minus then equals to 3 raised to power 2. So in this case 3 cancels 3. X minus 4x, that is minus 3x, then minus 8y equals to 2. So this is my equation 1. So this is my equation 1. And my equation 2 becomes x plus 4y equals to 0, equation 2. Now I don't have the same coefficients in any of my unknown. So here is minus 3. Bring it here. That is minus 3. Here is 1 times 1. So 1 times minus 3x is minus 3x. 1 times minus 8y minus 8y. 1 times 2 is 2. I call this equation 3. Minus 3 times x minus 3x. Minus 3 times 4y minus 12y. Minus 3 times 0 is 0. I call this equation 4. So I bring my minus to eliminate. Minus 3x minus 3x is 0. Because here becomes plus 3x plus 3x. That's 0. So here is minus 8y minus 12y equals to 2 plus 0. Minus 8y minus 12y. So here is minus 8y. Minus times minus is plus. Then equals to 2. So minus 8y plus 2y is 4y equals to 2. Divided by 4, divided by 4. 4 cancel 4. Y becomes 2 here 1, 2 here 2. 1 over 2. So I will say substitute y equals to 1 over 2 into equation 1. And my equation 1, let's use equation 2 for simplicity. So here becomes x plus 4y equals to 0. So here is x plus 4 multiplied by 1 over 2 equals to 0. So here is x, 2 here 1, 2 here 2. So here is x plus 2 equals to 0. X becomes 0 minus 2. X becomes minus 2. Therefore, x is minus 2 and y is 1 over 2. So this is the end of the second part of indices involving equation. So this is indices involving simultaneous equation. Now the last part is indices involving quadratic equation. So we have gotten to the last part of indices involving equation. So we did one of linear equation. This is simultaneous equation. No, we did simultaneous equation also, and this is quadratic equation. Now, question 1, I have 2 raised to power 2y plus 2 minus 9. I have 2 raised to power y equals to minus 2. Now, your goal is that whatever is here, the same thing appears here. Whatever is standing in brackets below, the same thing appears here. So which means that here, I'm taking it back to how it's supposed to be, which is 2 raised to power 2y times 2 raised to power 2. Don't forget that if you have the same base and you have multiplication between them, you pick one and add the power. So I got it back. Minus 9, I have 2 raised to power y equals to minus 2. Now, I will separate this 2 from y. It becomes 2 raised to power y times 2. What is y times 2? 2y. What is 2 times y? 2y. So I did not alter anything. It's still the same thing. Times 2 raised to power 2 is 4. Minus 9. I have 2 raised to power y equals to what? Minus 2. Now, I have 2 raised to power y and 2 raised to power y here. And now make them what? 1. And I will say, let 2 raised to power y equals to p. So here becomes p. This raised to power y is p. I have 2. Bring it here. That becomes what? P squared. Multiply by 4 minus here 9p equals to minus 2. 4 times p squared is 4p squared minus 9p. I bring this one inside. That is plus 2 equals to 0. This is now a quadratic equation. Now, for quadratic equation, I want to factorize. The first thing I do is multiply my a by c. Now, the origin of quadratic equation, or the equation of quadratic, is ax squared plus bx plus c, which means the coefficient of my square is my a, and this is my c. So here becomes 4 times 2, which is what? 8. So I come here, I have to be 4p squared minus 9p plus 2 equals to what? 0. Now I will look for 2 numbers such that when I multiply them together, it gives me 8. Those same numbers, when I add or subtract, it gives me minus 9p. So which means that the middle number is sum of roots. The last number, that is equal to our c, is product. If you remember your alpha, beta, sum of roots, product of roots. So 2 numbers such that when you multiply them together, it gives 8. That's our factor from our a times c. And once you add or subtract, it gives what? Minus 9. Now those 2 numbers are minus 1 and minus 8. So which means here becomes 4p squared minus p minus 8p plus 2 equals to what? 0. Which means minus 1 times minus 8 is what? Plus 8. Because minus times minus is plus. And minus p minus 8p is minus 9p. Just like doing minus 1 minus 8. So I have it in brackets here. Here is p. It becomes 4p minus 1. Minus here is 2. Because 4p minus 1 equals to 0. So the ones hanging outside put them in one bracket, and one in bracket, pick one. So here becomes 0. So which means that here is p minus 2 equals 0. P becomes 0 plus 2. P becomes 2. Or 4p minus 1 equals to 0. 4p 0 plus 1. 4p becomes what? 1. So divide by 4, divide by 4. So my p is 1 over 4. But we are not done. Don't forget that we said here that let 2 raised power y equals to p. So for the first part, 2 raised power y equals to p. That is 2 raised power y equals to 2. Now, I have a visible one here. I'll put this here. 2 cancel 2, y equals to what? 1. Then here becomes 2 raised power y equals to p. That is 2 raised power y equals to 1 over 4. So let me have it here. So here becomes 2 raised power y equals to 1 over 4 becomes 1 over 2 raised power 2. So here becomes 2 raised power y equals to, this is a positive power. If I bring it up, becomes what? Negative. That is 2 raised power minus 2. 2 cancel 2. Y is equals to what? Minus 2. So therefore, y is equals to 1 or y is equals to minus 2. So that is the first part of indices leading to quadratic equation. So we start number 2. I have 5 raised power 2x plus 4 times 5 raised power x plus 1 minus 125 equals to 0. So here becomes 5 raised power x times 2. X times 2 is 2x. 2 times x also what? 2x. Plus 4 times here becomes 5 raised power x times 5 raised power 1 minus 125 equals to 0. Don't forget, when you have two numbers the same base, you pick one and add the power. So I separated them. So here I will say let 5 raised power x equals to p. Here becomes p squared plus 4 times p times 5 minus 125 equals to 0. Here is p raised power, that is p squared. Here is 4. 5 raised power x is p. 5 raised power 1 is 5 minus 125 equals to 0. So here becomes p squared plus 20p minus 125 equals to 0. So this is quadratic equation. So the first thing I do is to multiply a by what? By c. A by c. So here is what? 1 times minus 125 equals to minus 125. So I'm looking for two numbers, which when we multiply them together, it gives us minus 125, and when we add or subtract, it must give us what? 20. So can we use 15 and 5? So we do 15 multiplied by 5. That should be 15 times 5. Okay, that is 75.
Action.
So two numbers which when we multiply them together gives minus 125, and when we add or subtract gives 20. That is 25 and 5. So here becomes p squared plus 25p minus 5p minus 125 equals to 0. 25 minus 5 is 20. So I'll put in brackets. What is common here is p. Here becomes p plus 25 minus here 5 is common. Here is p plus 25 equals to 0. So the ones hanging outside the bracket, here becomes p minus 5. The ones in the bracket I pick one, that is p plus 25 equals to 0. So here is p minus 5 equals to 0. P becomes 0 plus 5, P becomes 5, or P plus 25 equals to 0. P becomes 0 minus 25, P becomes minus 25. So we are not done. But I said here that let 5 raised to power x equals to P. So here becomes 5 raised to power x equals to 5. I have a simple one here. This cancels this. X equals to what? 1. The second one is 5 raised to power x equals to minus 25. So here becomes 5. No, this is our final answer. 5 raised to power equals to what? Minus 125. Because if I have 5 raised to power x equals to minus 5 raised to power 2. Now, there is no how. I have to bring the power down. So this is my final answer. 5 raised to power x equals to minus 25. So this is the end of the whole of indices. Laws of indices. Select from the laws, we move to the algebraic powers, and we move to the what they call it, the equation. That is the one involving linear equation, simultaneous equation, and quadratic equation. So that is the end of this class. Please make sure that you like and subscribe to my YouTube channel. Thank you. See you in the next class.